Hello, everybody, and welcome to the AWS Summit Online. My name is Todd Golding, as the slide says, and I'm a partner solutions architect at AWS, and I'm part of a team that's called the SaaS Factory. And that team basically helps organizations that are in various stages of adopting SaaS on AWS, building, optimizing, and so on. And one of the really common things we see with these organizations is that they are often coming from an environment where they basically have more of a traditional software setup, where they are offering a product, they're installing it on premises, or they're installing it in the cloud. And each customer basically will have their own configuration, and they're managing each of these customers differently. They're allowing them to run on different versions and so on. And what they find is that this becomes a real scale challenge for their business, right? They can't grow as fast as they want. They can't innovate as fast as they want. And they find it just to be super cumbersome to be able supporting each one of these sort of environments independently. And so this is where the appeal of SaaS really comes in for these organizations, because they see SaaS as a way to put all of these customers in a unified environment where they can be managed all collectively, operated collectively, and you can get real economies of scale out of that experience. And this becomes a real competitive advantage for these organizations. So they're really interested in moving from this classic sort of environment into this multi-tenant SaaS environment. And so that's what we're really going to look at today, which is how do we sort of take these legacy environments and what are the patterns and strategies and mechanisms that are available for us to migrate from this traditional model into a multi-tenant SaaS environment. Well, now, as much as we'd like to talk about the full spectrum of this, today we're going to focus our attention more on the technical dimensions of this problem. But I definitely encourage you to look at the SaaS Factory content that's available at AWS that looks at all the business dimensions of this as well, because they're equally as important to the technical bits. Now, anytime we're going to do migration, one of the things we have to ask ourselves is, like, what are the trade-offs of our migration strategy? And this is really a classic sort of software migration story. On one end of the spectrum, we have all the things that we really want to achieve. We have agility and innovation and modernization, and we really want to get all this sort of cloud goodness in our application. At the same time, we face real business realities, which are, we have time to market, and we have competitive pressures, and we have other bits that are pulling at us that are forcing us to accelerate as fast as we possibly can. So as we look at these different migration approaches, you'll have to sort of find out what the alignment of these trade-offs are that's best for you, and kind of what you choose here will probably determine which of these migration approaches best suits your particular domain and environment. Now, before we can dig into the different patterns and strategies, we sort of have to look at the overall landscape of what it means to migrate to a SaaS environment, because independent of which migration strategy we choose, there are some really common themes to what it means to land your solution in a SaaS environment. So when we look at sort of the landscape of what it means to land in a SaaS environment, yes, we have this gray box, which is where our architecture is going to land. But the reality is your solution, your architecture, is going to be just one piece of the SaaS puzzle. The truth is, to make this a truly multi-tenant environment, we have to surround that architecture with lots of moving parts that support our multi-tenant experience. So we look at some of those pieces. Onboarding, for example, how do we get tenants into the system? How do we create a tenant? How do they register and sign up for our product? Or what internal mechanism do we use to sign them up? How do we do identity here? How do we connect a user to an actual tenant? So as we authenticate and we get into the system, how do we create the binding between those two and then flow that through the whole experience? The other piece we have to look at is metrics and analytics, right? We're going to put all these tenants into this common environment, and we need some way to get better data about what they're doing, because now that they're in some unified experience, we have to see how tenants are pushing the different aspects of our system and how they're imposing load. And if you don't really have good metrics and analytics on a multi-tenant environment, you're sort of blind to what's going on under the hood of your system, and it becomes very challenging for your operation side and your product side of your business to know how to react and respond. As part of this move also, you tend to be looking at new models for monetization. So you might be moving to a consumption-based model, or you might be moving to some new sort of licensing scheme for your product. And this usually comes with the creation of a new billing and metering model, some way that you're going to express how customers are consuming your system and then turn that into an actual bill. We also have to look at the operational dimensions of this problem. If we think about it, having a multi-tenant system, we can't just pick up the traditional tools and technologies we've used to operate our systems in the past. We have to have some way to look at how tenants are actually using our system. Imagine somebody coming to you and saying, hey, a tenant is actually having a particular problem. As an operations person, I need to be able to drill into that experience and see what's actually going on for that tenant. So here's a situation where you'll find yourself needing to build new tools and new mechanisms to be able to really support a full, rich, multi-tenant operational experience. And then, of course, here we have automation and deployment, right? Automation and deployment is really just classic DevOps. But in a SaaS environment, we're really talking about zero downtime. And when we talk about zero downtime, we're really going to push the envelope of DevOps here. And we're really going to ask ourselves to build a really rich DevOps experience where we're taking advantage of all the features of DevOps, A/B testing, dark launches, canary releases, because these will all make a better experience for our customers, and they'll allow us to sort of push features and functions out in a way that we can test them as they land in the market. Now, the last piece of this lands in the middle of the box, and that's tenant isolation. But this is still a horizontal concept that we want to think about across our entire implementation, which is how are we going to keep one tenant from somehow inadvertently affecting or getting to the resources of another tenant? And this is just a fundamental thing that we have to build into our solution. So today we're going to focus more about migrating and getting our solution into this box in the middle. But by all means, as you go look at other content, think about all these other bits that you have to build around that box to have a full, robust SaaS system. Now, before we can get into migration strategies, we need to build a little bit of a foundation of terminology here and look at some of the sort of common ways that you could land your migrated solution inside of AWS. And so here you'll see three different models that represent the common models that we'll see organizations migrate into. And on the left-hand side, you'll see what we call the silo model. And in this silo model, basically, we're saying each tenant is going to run in their own stack. They're fully isolated, really common model that people will land in. And then as an extreme, on the other end, you'll see on the right-hand side what we call the pool model. And the pool model is basically one where all the resources are shared by all tenants. And here's where we get the economies of scale and some of the goodness of agility and innovation that we're really striving for as a SaaS provider. And then just because not everything is either silo or pool, we also have in the middle here what is called the bridge model. And the bridge model is sort of meant to represent the idea that some portion of your system might move to pool while other bits will remain in silo. And so as we move forward here and we look at migration strategies, keep this silo bridge pool kind of mindset at the top of your mind, because this is going to be part of how we think about our overall migration approach. Okay, enough of the foundational bits. Now let's really look at what are the core sort of migration approaches that we're going to look at here today. And these three represent three really common approaches, but they're not necessarily every possible way you could do it, but these represent some of the patterns that are really common that we see as we help SaaS organizations. And the first one on this list is what we call silo lift and shift. Silo lift and shift basically is moving your existing stack of your application. It's basically saying leave it in its current state as much as possible and lift it and shift it into a SaaS model. And this obviously is directed very much at a time to market kind of model and it's sort of focusing on being minimally invasive. The next model we'll look at is what's called a layered model. And this very much correlates to the bridge model that we saw above, with the basic idea that we'll take a portion of our architecture, we'll try to leave it very much as it is, but we'll move it potentially from a silo model to a shared pooled model. So here you'll see the web application, the web tier of our environment, of our monolith, has become a pooled model where the rest of our application has stayed in a silo model. And finally, the last model we'll look at is what's called service by service migration. And this approach is really focused on really moving to a fully modernized SaaS architecture and carving out the services incrementally out of your system that are best practices microservices. Okay, we've got those three as a backdrop. Now let's wander into each one and see what the trade-offs are between each of them and how they're actually built on top of AWS. And of course, we're going to start with this silo migration model, right? This silo lift and shift model. And again, the basic idea here is leave your stack exactly as it is and move it into that gray box that we talked about earlier and surround it with all the moving parts of a SaaS environment. So if we look at what that will actually land in AWS like, if we look at what the sort of mindset behind this model is, it's pretty straightforward, really. We're going to take your stack of your environment, we're going to deploy it into this managed environment where it sits alongside of all the other tenant environments, and each tenant in here will have their own stack. Now, one of the core principles of this environment is that we are going to land these tenants as mirror images or clones of one another. So we're not going to allow each tenant here to have their own version or a special configuration. They all have to be the same sort of stack of services, the same version of the product, because if we allow these variations to find their way in, we essentially work our way back to the model we started with in our legacy environment, and we get all that challenge of managing and monitoring these environments in a universal way. Now, we also have here those core concepts that I talked about earlier, those horizontal concepts, tenant onboarding, registration, all these sort of shared concepts. You'll see this across all of the slides as a placeholder and a reminder that these core concepts have to find their way into every solution that you're going to build, every SaaS solution you're going to build, that is. And then once we have all these pieces in place, the next thing we need here is some way to route traffic to these individual tenant stacks. So you'll see here, we come in, we authenticate the tenant, and then we have some notion of tenant routing, and we'll look at what that looks like in more detail in a moment. But essentially, there's something that looks at who you are as a tenant when you're coming in and routes you to the appropriate stack. Now, the last moving part of this silo lift and shift model is the onboarding of a new tenant. And in this model, even though we have a separate stack for every tenant, we still want that onboarding process to be as frictionless as possible. So here, what we're going to do is introduce automation and deployment automation that will essentially take our full stack isolation and deploy it through our DevOps process into this shared environment alongside all the other tenant environments. So now it just moves in a fully frictionless experience. It gets onboarded and a new tenant just shows up in our environment. And this is where you have to invest in really rich DevOps and really rich onboarding mechanisms to ensure that these tenants get created in a fully automated fashion. Now, what are the ways you would achieve the routing in this environment? How would you route tenants to these individual stacks that you're provisioning? Well, this will vary based on the approach you want to use, but I wanted to at least highlight two approaches to this. So the first one we'll look at is domain-driven design. And the basic idea of domain-driven design is that we're actually going to have a separate domain name or a subdomain for each one of the tenants in our system. So when they sign up and they register and they get onboarded, we'll give them this domain, and then we'll just use classic DNS routing here to route these tenants to the appropriate stack in the system. So in this example, I have tenant 1 and tenant 2, and they're both going to route based on that subdomain and then land in their individual stacks. And this is a really classic way that works really well. Now, if you move on and you look at an alternate approach, one that maybe doesn't rely on a domain and where somebody essentially says, I don't want independent domains for individual tenants. Instead, I want a shared domain. In this model, then we have to rely more on data. And that's why we call this a data-driven routing scheme. Here, our tenant context is embedded in the JOT token that flows into here, our authentication token. And then our API will look at that JOT token and say, oh, you're tenant 1 or you're tenant 2, and it will figure out how to route you to the appropriate stack. And so this happens somewhat transparently to you because you're just hitting a generic API and endpoint, but you still get routed to the appropriate stack through some sort of routing context. So both of these models are perfectly valid and work really well. It really comes down to what are the preferences for your environment. Finally, we want to look at what this lands like as in an actual AWS environment. Like, well, how would you set this up and provision this and configure this in your environment? So I provided an example of what this might look like. Here you'll see In this example, I've pushed the web application out into an S3 bucket and assumed that we have some sort of single page application. You may have your application still hosted down in the VPCs down below, but here I presumed you might have moved to a modern application framework. That's coming through an API gateway. And then there's where we pull off the tenant context in this model, get your tenant ID, go through the application load balancer, and ultimately land in the appropriate VPC that belongs to individual tenants. So on the left, we have tenant one's VPC, and on the right, we have tenant two's VPC. And yes, I've shown some infrastructure here, but the reality is, it's the key takeaway actually here is that we have a VPC per each tenant. Now you could have used an account per tenant or other models, but VPC per tenant is often what people will use here. And then what lands inside that VPC will really depend on what the stack of your actual application is. Finally, as part of silo lift and shift, we should also look at how you're actually going to manage this environment and where all these horizontal concepts that we talk about land. So we talked about onboarding and metrics and analytics and billing. Well, those don't land in the tenant VPCs. Instead, you have to have a separate shared services VPC. And that's where all that shared mechanisms will live. And then that shared VPC will interact with the different VPCs that are associated with your tenants that you see on the right-hand side in this diagram. And here in this diagram, I happen to show VPC peering as the way that that interaction would happen. But the reality is you have a lot of choices there. And each of them sort of have pros and cons. Private link is often a good fit here. Event bridge is often a good fit here. It really just depends on what's the best for your particular environment. Okay, let's now move forward. Silo lift and shift really gave us sort of a baseline, like just lift it and move it as easily as we can. Now let's move to layered, which layered really says, how can I modify some aspect of the architecture without totally rewriting it, but start to get some of the multi-tenant goodness that I'm after? Now, with layered migration, what we want to do is look for an opportunity in our environment to sort of carve out a piece of the system that we can turn into a pooled architecture without sort of rewriting it in any significant way. And what we find here is that the web tier of your application is often a fantastic candidate for this. So what you'll see here is the web tier of our environment has essentially been pulled out from the siloed experience and turned into a multi-tenanted pooled environment. Now, it's still written very much as a monolith, but now because it's running in a multi-tenanted construct, we essentially can take advantage of all the elasticity of AWS and all the advantages of just having a pooled model that scales based on the actual load of tenants. And this gives us economies of scale. It gives us a better operational story. And it's only for a sliver of our system, but now this gives us a first step towards moving to something that reacts and responds based on the actual activity of tenants in our system. So if you look at this, you'll see on the right-hand side, we certainly have all those shared constructs that we had before. And now when we come in, our tenants authenticate and they come into the environment, they'll come into this web tier, and then they'll need to be routed to whichever app tier that is the appropriate app tier for this environment. So you'll see here I have app tier and database still running very much in a siloed model for each tenant. Now, the last moving part of this is obviously deployment automation here. How are we actually going to deploy tenants in this environment? Well, now that the web tier is shared, we only have to deploy a smaller piece of this. So here now, when you look at our deployment, what we're deploying is actually an app tier and a database for each individual tenant. So the footprint of what gets deployed is smaller here. Same value system, still wanted to have all the automation and provisioning that we have here, but a pretty straightforward model. Now, the next sort of layer of this, if you will, is to look at, is there another opportunity for us to move another layer to this sort of shared or pooled model? And what some will do here is say, I'll take that web tier, and now I'll actually take my app tier, and I'll actually move the app tier itself to a multi-tenant model. Again, not rewriting it, leaving it very much as a monolith, but now in this monolith, I'll do the extra work, the extra refactoring to introduce the support for multi-tenancy here. And now the app tier of my environment will scale dynamically, just like we discussed with the web tier. Now, this effort will be a little more than it is with the web tier, and it could be so significant that it may not be worth it. But if you can get here, now when you come through the web tier, now you hit that shared app tier, and now we just route to individual databases for each tenant. And this gives us a huge advantage because now what we need to provision is a lot less. If you look at the DevOps story here and the automation story, our only thing we're deploying for each individual tenant is the database for that tenant. And what I tell some people is for some organizations and some domains, depending on the dynamics of your market, this may be a perfectly valid ending place for your application. You may say, even though it's still a monolith, it's a pooled monolith, and I am getting good elasticity out of it, and it may be good enough for my environment. The last model we're going to look at here is the service by service migration model. And so far, we started at silo lift and shift. We moved a little bit more with the layered model. And now with service by service migration, we're really saying, no, we're really going to try to get to the end state that is the target end state for our application in an incremental fashion. And we're going to move away from that monolith and move to a more modern architecture with microservices. And this model, in fact, often is called the strangler pattern. So let's look at what you start with here. You'll see that the starting point of this is very much the same starting point as our other monolith. We still have the sort of full stack isolation, maybe because we still start out with the same sort of siloed environment we had for each of our tenants. That doesn't go away here in the service by service migration model. It's there as our starting point. And we still have the shared services that we mentioned earlier. But now what we're going to do is say, is there some functionality in the app tier of our application that we can carve out and implement as its own microservice? So here you'll see an individual microservice that's implemented. And now this microservice is implemented as a cloud native, multi-tenant best practices microservice. And now as traffic flows into our environment, it flows into the web tier. And for those things that still have to be processed by the app tier, they will. And for those things that can use our new microservice, the web tier will interact with those. Now, the hardest part of this service by service migration model is finding that first initial service to carve out, because it's often sort of interwoven into your application tier, and it's sort of difficult to carve out and put on its own. But you have to start somewhere, and so you pick a good service here and carve it out. The other piece that you have to carve out here is the actual database part of it. And that's where it can get very sticky, especially if you're using stored procedures and other mechanisms. But either way, this is generally how the service by service migration works. And if you get the service not exactly right at the beginning, that's fine. You can expect that you'll need to iterate in here. Now, another variation of this model is the model where we will actually say, how can we even move more away from that app tier and move more to a pooled model and focus more of our attention on just what it means to have that app tier carved into individual microservices. So in this diagram here, you'll see that I have broken the web tier of the application actually out. And that web tier is running very much like we did in our layered model as a pooled model. And so now as traffic comes into that web tier, it responds elastically to the tenant load, and it routes either to the silos that are my app tiers or to my individual microservices that I'm carving out. And this at least gets the web tier separated from the app tier and puts us on a path to a modern application. The natural evolution of this is in this next variation that we'll see, where we'll now go to a fully modernized architecture where we'll move the web tier of our application out to a single page application hosted on S3 and served and hosted in the browser of your application. And this may mean you have to rewrite the web tier of your application. And that may be too much for some organizations. However, if you can make this move and get the web tier over there, now you've essentially moved all the old legacy bits out of the middle of your monolith, if the sort of server side of your monolith. You're now serving all the client from the edge there. And now you're coming through the API gateway and interacting with your app services. And the best part of this is, as you carve out more and more microservices here, eventually that silo will go away, and all you'll be left with is the microservices of your environment. And that essentially will be a fully modernized environment. So this is the end state you're ultimately targeting. Now, if you wanted to look at like a basic sample architecture of this, it's pretty straightforward. We're going to have the S3 hosting our web app. That's going to go through the API gateway. Then that'll hit the application load balancer, and then that will hit the sort of monolithic bits of our application running in individual VPCs. And then alongside that will be our new service. And here I've got a set of Lambda functions that are hosting my new service. And you'll see that now as requests come in and go through the API gateway, they may go directly to my new microservice. Now, what I do have to allow for here is my existing monolithic code may still need to interact with this service as well. So you'll see that we have to add one more interaction here to account for the fact that this code may have to be refactored slightly to interact with our new microservice. The last point I want to make here on this service by service migration is that this move to these microservices is your move to a modern architecture. So I'd like you to avoid bringing in any of those legacy bits into this new microservice and really build this microservice as your next generation sort of model here. So in this microservice, we'll want all the best practices of SaaS. We'll want to break out the logging and the metrics and the data access. We'll want to hide away the details of tenancy, all these bits which we talk about in more detail in more SaaS factory content. But the basic idea here is even tenant isolation should be baked into this. So when we're all done with this microservice, it'll look like a best practices multi-tenant SaaS microservice and something that will set the stage for the rest of the microservices that we'll build in our system. Finally, let's look at some of the pros and cons of these different models. So if you look, for example, at the silo lift and shift model, the pros and cons are probably pretty straightforward here. Obviously, this is the fastest path to market for you and the least invasive approach that you can get. So for those organizations that are just in a huge hurry to get to SaaS as fast as they possibly can, this can really represent the best option for them. Obviously, it comes at a cost a little bit. Your agility and innovation will be slower. The cost and management is less than ideal in this space, but can still be a very compelling place to start. The layered model gives us an incremental path more. We can start to move some of the bits of our monolith to a pooled model and take advantage of shared infrastructure. And we can do this without this being a massively invasive effort, but it's still more work than lift and shift. And we still get some of the downsides of cost and management here because we still have lots of the monolith in this space. The last bit, service by service migration. This is all about saying we're making a big commitment to get to a fully modernized architecture, and we're willing to move to market a little slower as a result of that. And so here you'll see we get all the cost and the agility that comes with being in a modernized environment and a lot of the goodness that we're targeting with SaaS, but we'll have to sort of pay for that by maybe moving a little slower, adding a little more complexity as we figure out how do we actually carve our system up into these microservices. Now, a few things I would like you to think about as you go away and think about your migration strategy. One of the things I really want you to keep in mind is that even though it may seem like you have a lot of time, I would encourage you to add a degree of urgency to your migration, because you never know when another product is going to be offered in your space or when a new competitor might come along. So try to pick something that can add more urgency to your rollout of your product. The other thing I want you to think about here is, even though we didn't get to talk about all these other bits, onboarding, registration, and sort of all the metrics and analytics, these are still core concepts. And you should go away and look at the other content we have on these topics and consider those like the foundational bits of getting your SaaS migration off the ground. The other piece here is that I definitely want you thinking about this being multi-tenant on day one. And that may seem sort of obvious, but some organizations will actually start out with a single tenant solution and then think, well, we'll add tenants eventually. And that ends up really having a big penalty for them as they end up needing to refactor or rewrite parts of their application because they didn't factor in important aspects of multi-tenancy from the beginning of their system. The other bit here is that metrics are a key part of SaaS. Right? As you put all your tenants into a shared environment, the only way you can really tell what's going on is by having really good metrics and analytics that tell you what's going on under the hood. What are tenants exercising? Which features are they using? What parts of the system are they placing load on? And you'll need that at the dev phase, even before you go to production. It's just essential to running a really good multi-tenant environment. Obviously, as part of that, we also want you thinking about just generally, what will the operational footprint be? So as you migrate in, I want you to build these multi-tenant operational tools that will give you views into which tenants are healthy and which tenants aren't healthy, and how you will support the system and be able to have somebody be able to come and look at through your operational view what individual tenants are doing in your system and troubleshoot problems. The other bit here is I definitely want you to work iteratively here, right? Go away and build little bits of onboarding, little bits of metrics and analytics, and then let the whole thing mature together. I tend to find that experience leads to a better overall product instead of working in individual silos. And finally, the last bit here is that the whole reason you're going through migration here is to really achieve agility, right? And so ask yourself all along the way, are we doing the things that are going to make this an agile solution? Do we have fully automated onboarding? Do we really have the management and monitor experience we need? And challenge yourself to come up with something that's going to really get you to the SaaS experience that you're after. Okay, so that wraps up my session. I hope that really gives you a good sense of just what's involved and what strategies that people often use when they're migrating from a single-tenant environment to multi-tenant SaaS, and really give you a sense of the patterns that are available to you to go away and start this journey for yourself. Again, my name's Todd Golding, and I really appreciate you joining my session. And I definitely encourage you to go and look at the other SaaS Factory materials that are out there and really get more in depth on some of these topics. Again, thank you so much and enjoy the rest of the online summit.